Um, Welcome everyone to the ICAI Amsterdam session. As indicated below, we have, we will do the questions via the chat. I will look at them as a moderator and will answer the questions at the end of the session rather than at the after each talk, because we have, after my presentation, three more presentations. So it will be a little bit condensed if we have questions in the middle. So Amsterdam is a vibrant AI city, and in the Amsterdam AI Coalition has put themselves together under the AI Technology for People group, which contains all the parties that you see here. So the Amsterdam Economic Board in the City of Amsterdam, Sanquin, the Netherlands Cancer Institute, and the hospitals, the Amsterdam UMC, the Amsterdam University of Applied Sciences, the Center of Mathematics and Computer Science, and the VU and the UVA, and we all work together on common themes and as part of the Dutch AI Coalition. And together we are educating around 7,000 students who either are in a full AI program or in their programs at least get a part of the AI knowledge that they would need. So if you look at the science behind AI technology for people, we have three main fields that we work on. So the big one is machine learning, and machine learning we do from multiple perspectives. So we do geometric deep learning, we do computer vision, we do natural language processing, but we also do knowledge-driven AI, symbolic AI. So that's one big component. We do also, as we just heard in the KPN presentation, or the KPN lab, we do a lot in responsible AI, where we approach it from two sides. So we approach it from the technical side, so the machine learning, the data science techniques that you need to do responsible AI. But we also have people working in humanities, people working in law, who approach it from the other side, and that's what we try to bring together. And finally, we have the hybrid intelligence, also with the hybrid intelligence gravity program that we run from the VU, in which we bring people together with the machine. So rather than seeing them as two isolated systems, or you have the machine and the human, we really bring them together to give them more intelligence than otherwise they could give. And we work on three main domains, three big domains. So we work in health. Well, as you saw, we have the hospitals, we have Sanquin, so we have a lot of end users within the city already, but also a lot of research in that area. We work at business innovation, and that's especially focused on the service industry. So from tourism to fintech and everything in between, retail as an important component. And we work for the city itself. So we work for the citizens within the city and try to make their life better with AI systems. And this is also the blueprint for our presentations today. So we have three example ICAI labs that we will present to you. So the first is the AI in oncology lab. So that is one that is recently started, but at least we already have some, there are already people starting there. So it will be presented by Clarissa Sanchez. Business innovation, Onno Soeter from Booking.com will present the Mercury lab, which hasn't started yet, but it will start very soon. And there's someone that should be mute himself there.
I've muted them. It's okay.
Okay, thank you. And the final one on citizens is the Civic AI Lab, which will be presented by Senna Gabriel. So as we have only half an hour, I would immediately like to give the floor to Clarissa. So can you please share your screen, Clarissa? And I will stop sharing. Oh, she already did. Good.
Yeah, hope you can see.
Yes, well, we see, not your presentation mode. Yes, there it is.
Yes, okay, perfect. So yes, I'm going to present the lab that is between the Netherlands Cancer Institute, NKI, and the University of Amsterdam, and is focused on AI in oncology. And unfortunately, I don't have to introduce cancer. I think it's a very well-known disease. In the last year, there was 2.7 million new cases and 1.3 million deaths. So unfortunately, we can't relate to it in one way or another. The positive things is that there are a lot of advances in cancer research that have the potential to save life. And NKI is very on the lead of this cancer research, trying to address it from different type of views, from fundamental research to image-guided therapy, immunotherapy, precision oncology, and survivorship. And AI in oncology represents an opportunity to take bigger steps forward in this research. And taking into account the AI research being done in the Informatics Institute at the University of Amsterdam, there was definitely, we can say, a match made in heaven to create this lab of AI in oncology lab. And what we would like to do here is to create an ecosystem focused on AI technology for oncology for the improvement of diagnosis and therapy of cancer. So what we would like is to take the groundbreaking research that's being done at the university and pass it on to the cancer research being done in NKI. So then later we can really integrate the solutions for patient care. And this is our team. So together with Jan Jacob, we are the scientific directors, and Jonas Stern is the lab manager. And as Marcel said, we are starting recruiting the PhD students and the researchers now to just start it. And I'm going to present exactly the two projects that these students are going to focus on in the next 5 years. So this is the project from Shannon, and then she is focusing on AI-based risk and outcome prediction in calcified breast lesion. And just to explain you the problem is there are some lesions that women can have in the breast that can lead to cancer, but not all of them lead to cancer. And unfortunately, those ones that are suspected for leading that, well, all of the women that have this DCIS, so it's a ductal carcinoma in situ lesions, they are all treated with one or several therapies, for example, with surgery or with radiotherapy or chemo. Taking into account that not all these lesions advance towards an invasive breast cancer situation, and some of the women wouldn't need to do anything because these lesions are indolent, then we are treating a lot of women, and we are putting them, and they are suffering the mental and physical consequences of the treatment. So what we would like to do in this project is trying to see if we could identify those women that are going to progress to these invasive cancer situations, and only those one treat, and the rest shouldn't treat. So this is the project from Shannon. And for the project of George, we have active MRI acquisition of and real-time tracking of tumors and organ at risk during MRI-guided radiotherapy using AI. So we have now a machine that we can image the patient at the same time that we provide the treatment, in this case, a radiotherapy. So we have the opportunity to monitor where the tumors and the organs are. For example, in this case, you can see that if the tumor is in that region, I don't know if you can see my mouth, but it's here, that we are missing base of movement, in this case for the respiratory movement. So what we would like is to adapt and try to track the tumors during treatment, so we can provide the best and the most efficient treatment for the patient. And that is all. Thank you very much.
Thank you. So let's move to Onno for the second presentation.
Hi, good afternoon, everyone. I would like to give you a teaser introduction to an upcoming AI lab. So this is one of the upcoming labs that Marta already hinted at in his introduction. It's the Mercury Machine Learning Lab, where Mercury is the Roman god for travelers, amongst other things. And this is a collaboration between Booking.com, the University of Amsterdam, and the Technical University of Delft. And then once we're formally launched, we'll have, of course, more information, and my counterparts from the University of Amsterdam and Technical University of Delft would be here as well. But I want to take this opportunity to give you a little bit of an insight why Booking.com started a lab and an introduction of the topics that we hope to cover. I head up what we call B.Rain, is Booking's research on AI network, which is our open innovation arm within Booking. And the Mercury Machine Learning Lab is one of the first big initiatives under that banner. And the reasons why we do this, so we have 100+ people in-house, experts on machine learning and artificial intelligence, and many already with a PhD. But there are several reasons why I think it's worthwhile to collaborate with universities. One is that it's a very effective way for us to follow state of the art in this very fast-moving field. Of course, we want to let people know about the job opportunities at Booking. So again, as Martin in his presentation mentioned, that now retaining talent is one of the goals. So we hope to contribute there as well. We want to grow and motivate our internal people. I think that for people that have an academic background, it will be fun to keep engaging with professors and students. And I think, like nearly everybody here today, we want to give back to the community, and we want to help grow the AI ecosystem in Amsterdam and in the Netherlands. We have our headquarters in Amsterdam, and it's of course for us very important that that there is a growing, that there's a healthy AI ecosystem there. Of course, for every project that we do, we of course hope to knock it out of the park. But even if that doesn't happen, I think there's a lot of value in having a lab. As mentioned, Mercury Machine Learning Lab, with 3 entities: University of Amsterdam, Technical University of Delft, and Booking.com. And so there are 2 main themes that we will cover in the lab. One is natural language processing, and the other is something that I call learning from controlled sources. And let me give you a quick introduction of what we mean by that. So for natural language processing, where it's University of Amsterdam and Booking.com will be involved. So the use case or the guiding application at Booking.com is that we operate in 43 languages. So if we build a natural language processing system, say moderating reviews or what have you, if we would build 43 independent systems, then A, that would be quite costly, and B, it would not be very accurate for the low data languages. And so the main goal of this lab is to keep track of and add to the solutions that make these multilingual systems from the get-go, so that it is less expensive to build and that the lower data languages can leverage the insights that are learned from the higher data languages. And we hope that we can bring a unique advantage of the real world platform that is Booking.com, so that in academic benchmarks, there would be algorithmic scoring of solutions such like the Bleu score. For us, we can put systems out and really verify that systems are already good enough for human users to use. So we get an addition beyond the assessment that would come only from algorithmic scoring. The other topic is learning from controlled sources, where all 3 parties will collaborate. And this comes from the following insight, is that if you build machine learning models and actually use them, there's an interesting difficulty that often arises, is that the data that you get is not only reflecting the system that you would like to study, it is a combination of the system that you like to study and the active control of whoever was trying to control the system before. Right? So in a hospital, you would want to understand the physiology of the patient and how to best treat the patient. But the data that you get is a combination of the signals that you get from the patient and the treatment policy of the doctors that were treating the patient. In Booking.com setting, it would be, we want to understand the preferences of people as they go about picking their ideal holiday. But what we see is a combination of those inherent preferences and what our ranking algorithms provide and what our highlighting algorithms and what our recommendation systems do. And the idea here is that we want to, again, understand all the tools that are already available, add to them, but on top of that, democratize, say, the use that these type of problems are acknowledged from the get-go and are not coming up as an afterthought after systems are running. And here it's quite interesting. We will bring three different academic disciplines together: information retrieval, the nascent subfield of statistics and causality, and reinforcement learning. And here the unique platform, real-world platform advantage that we hope to bring is that instead of just verifying what is, or just making predictions of what might happen if you would run a different control policy, here we can actually do, and we can actually validate. And if we compare again to the example of the hospital, mathematically, the problems are roughly the same, but in our situation, we can a lot faster and a lot safer experiment with solutions. So we do hope that the academic findings will find its way also in, for instance, applications as in the hospital. So thanks for that. This is teaser introduction. I'm sure we'll get back to you with more data and more information once it's launched. If you have recommendations or suggestions as we get going, we'd love to hear from you. And with that, Marcel.
Yes, thank you, Onno. And then we'll switch to Senai. Yes. We're still looking at your new functions in Safari, Senai.
So let me reshare my screen.
Yes.
So I hope you now correctly see my screen.
Yes, we do.
Thanks, Marcel, for the introduction. Happy to talk a bit about CWKR Lab. The lab is a public collaboration between the University of Amsterdam, the Free University of Amsterdam, the City of Amsterdam, and the Ministry of Interior Affairs in the Netherlands. And we basically focus on AI for social good and for equal opportunity. Let me tell you why we focus on this topic. In a study published last year, Vinuesa and colleagues attempted to answer the question, how is AI impacting society? And they focused on the 17 Sustainable Development Goals with 160 targets. This aim at a more inclusive, just, and sustainable society by 2030. And the first goal is, for example, to end extreme poverty. Another goals focus on health, education, sustainability, climate change, and also reducing inequality. And what Vinuesa and colleagues found was that AI has a positive impact on almost 80% of the SDGs on average, and a negative impact on 35% of SDGs, again, on average. What is striking is that the negative impact of AI is high predominantly in two SDGs, SDG 4, quality of education, and SDG 10, reducing inequality. We focus on SDG 10, reducing inequality. For this SDG, like for many other SDGs, AI turns out to be both an inhibitor and an enabler on almost all targets of reducing inequality. There are many reasons why AI enables inequality. For example, AI is often developed and used with the aim of optimizing speed or minimizing costs, rather than, for example, promoting equality of opportunity. Or AI is developed and used in ways that are blind to historical, social, and cultural context, and also inequalities, social inequalities. And sometimes AI is used to maintain status quo and existing power structures and relations. AI can thus perpetuate existing socioeconomic inequalities, but it can also help promote equality, equal opportunity, if it is designed and developed and deployed with that in mind, with that objective, and also with consideration of socioeconomic and historical context. And this is precisely what we aim to do at Civic AI Lab. The lab's vision is a society in which citizens from all walks of life, including those at the margins of society, can get an equal opportunity in society, can contribute to society equally, and can benefit from society in an equal and fair fashion. Our mission is to develop AI technology that promotes economic and social human rights, such as the right to health, the right to education and employment, while respecting fundamental human rights, such as privacy, non-discrimination, and equality. This is the organization of our lab. We have an advisory board with representations from each of the 4 lab partners. We have 3 lab directors, 2 from the UvA and 1 from the VU. We have 7 PhD students, of which 5 focus on specific social domains, and 2 focus on general ethical, legal, policy issues, challenges, and so forth. And we also have a lab liaison for dissemination and outreach of lab activities. And finally, we have 2 lab managers, 1 from the UvA and 1 from the VU. Each of the 5 specific projects, the main specific projects, aim at increasing action perspective on equality of opportunity in the city of Amsterdam with the help of new AI technology. For example, in the health project, we focus on fair machine learning models that go beyond the usual mathematical notion of fairness. In particular, here we focus on concepts like differential fairness, which builds on the intersectionality theory, which is a kind of an analytical lens from the humanities and the social sciences, which analyzes how interlocking systems of power and oppression affect individuals along dimensions, overlapping dimensions such as gender, race, sexual orientation, class, disability, and so forth. And in the education project, we develop algorithms for fair distribution of financial resources over kids and schools. And such algorithms allow, at least we hope to build such algorithms to allow decision makers to define undesirable machine behavior, such as discrimination and inequality in resource allocation. In general, the lab has 3 main research directions. The use of data that represents citizens better and deeper, the development of fairness measures that respect differences between citizens and communities, and the development of custom-fit algorithms that focus on empowering people and communities instead of focusing on technology itself. This is the last slide, and these are the talents in our lab that are working on using AI for social good and for increasing equal opportunity in society, in cities, and so forth. With that, I would like to end my presentation.
Thank you. And exactly 6 minutes. That's very interesting. You did very well. So we have some time for questions. Could be to any of the presenters that we had. During the talks, there were no questions. Well, there was one question asked, which was not directly related, so I already answered that one. Does someone have a question? Otherwise, I will. Okay, then I will pose one, and I'll start with Clarissa. So if you, in one sentence, would say what you would like to have achieved in 5 years from now with the lab, what would it be?
Definitely what I would like to see is that the things that we implement can reach patient care. So that the really patient care, so patients can benefit from AI research directly.
Very good. I think we all agree with that. That statement as a good thing to do. Well, now can I pose you the same question?
What we would like to achieve in 5 years?
So after, I mean, the lab will start, well, in your case, maybe in a month from now, but in 5 years from now, the lab will come to its end. What's the one thing, if you would say it in one sentence, that you would like to have achieved with the lab at that point?
Well, if I take two sides, so for booking and applications, I think there is a lot of opportunity to democratize in this general space things that might be known already, but to make sure that they are that everybody takes it without any hesitation, any thought. So a quick acceleration from something that might be in one professor's head or one paper now to something that everybody uses to great effect. I think there's a real opportunity that will do that. I also hope that my academic counterparts in 5 years' time would say, look, there were some very interesting and challenging questions that have sharpened the academic questions I've asked or the mathematical abstractions of problems that I've worked on. So on both sides, I do hope that in 5 years' time, people would look back and say, okay, that has really helped me. So both the academic side and the applications within companies like Booking. Yeah.
Thank you. Well, Senai, for you, the final moment to say that, to answer the same question.
There's a lot of doom thinking about AI, about data sciences, and to some extent for good reasons. What I hope is that in 5 years from now, citizens also realize that AI, data sciences, technology can be used for the good to empower themselves through very concrete examples of and applications of AI for good.
Okay, thank you. Then there's also now in the chat from Shane a question for me. So he's curious what or how knowledge graphs are being used in the labs. So the knowledge graphs, well, the principal one working on that is Frank van Harmelen at the VU. And it's used in many different projects. So he is leading, as I said, the Gravity program, so a large MBO program for 10 years, which is called Hybrid Intelligence. And I mean, their scientific man on the moon project, or person on the moon project, maybe better said, is to write a scientific paper together, so that a machine and a human are really contributing to a scientific paper. But they build knowledge graphs for all kinds of domains, whether it's medical or whether it will be in tourist data or in banking. In all of them, there's a lot of possibilities where knowledge graphs are being used. Okay. Oh, we have one more minute, so let's. Christina has a question. Are there planned opportunities for more senior researchers, not only PhD positions? Okay, I can answer that in general. So all the ECI labs, most of the ECI labs have a model where you have 5 PhD students as a kind of minimum. Sometimes those are PhD students in combination with postdoc positions, but from the kind of junior research level, those should be at least 5 people. Then there are lab directors, also as Senna was indicating, and also as Clarissa was indicating. So they are typically at the tenure track level. So assistant professor up to associate professor, and then there are 2 scientific directors, which are at the associate to full professor level.